the liquid refrigerant gets pumped into the stator, flows through the stator assembly, and then has these return drain ports out on the sides here and returns back to the condenser. Now let's look at this from a more blown out view at the schematic. So what's actually happening here is at the bottom of the condenser right here, we have a liquid tap that comes over to a liquid refrigerant pump. That pump is mounted to the oil tank and is driven by an internal motor inside of the tank. That pump then pushes that liquid refrigerant out and then up to the motor cooling inlet. It will then flow through the stator assembly and then out these drain ports, will wire back together and just dump directly into the condenser barrel. The whole point of this process is to use a little bit of our liquid refrigerant to keep our stator cool, as this is a refrigerant cooled system and this motor is a part of our refrigeration circuit. It is not external or air cooled like other chillers. To give you another depiction here, we're coming up from our refrigerant pump. We're pushing through this orifice here and then into our stator, and then we flow and drain back down into our condenser. Hi, I'm Holden Schamberger. Hope you're doing really well. We need to cover this fairly quickly. Got a lot to go over. Only got so much time to do it. With that, we're going to be going over secondary refrigerant cycles for CVH chillers. So that's going to be motor cooling, purge, and inductor. I'm with chilleracademy.com and HVAC Time. If you'd like to get some additional chiller training, go check out Chiller Academy, see what you think. Otherwise, let's get into our purge cycle next. The purge cycle can be a whole lesson all of its own, but we're going to cover just how the chiller's refrigerant interacts with it in this lesson, and then we can look at doing a deeper lesson later on the deeper specifics of the purge cycle itself, or the purge system. So keep in mind, with a purge, this is a low pressure refrigerant, meaning that we run in a vacuum for a majority of our operation. At a high load or high condenser water, the condenser barrel might get positive pressure, but it will usually float right at about neutral, if not in a vacuum. So with that, we have risk of drawing in non-condensables, and we need a way to remove those non-condensables from the system, aka our purge assembly. So what we have happen here is we pull vapor refrigerant in from the condenser, and it comes into our purge tank, where it has its own separate refrigeration circuit with an evaporator coil. This evaporator causes our chiller's refrigerant to condense, and it will drain down into our drain port and then leave the purge tank and go through a filter dryer and then back to our condenser as a liquid refrigerant. And our non-condensables are going to stack in the top of the purge tank. Once our purge compressor suction line breaks over a threshold. Now there's an actual formula for this, but typically it's about 28 to 18 degrees. Then we will enter a purge cycle, at which point a set of valves and a purge pump will open. Then we will pull the non-condensables off of the purge tank and push them out. Now we go through a filtration canister. The older machines just had look like a recovery cylinder, and it was just a canister with a filter in it that would capture the refrigerant and not let it leave. Newer regen purge systems have a carbon tank that purge tank vapor gets pushed into, and the refrigerant gets captured while the non-condensables flow out. It does not get captured by the carbon. And then when we go into a regen cycle, a set of valves will change over, and we will actually start up a heater inside of that carbon tank, and we will recover out the vapor refrigerant that got trapped, that was accidentally released when we were in a purge cycle. And that vapor, as it gets released from the carbon heating up, will get drawn back into the evaporator. So that is how, with a regen system, we're able to reclaim that lost refrigerant that would have normally gotten lost in the purge cycle. If you do not have a regen system, then it gets either captured by this tank, or very old systems just didn't have a tank at all, and everything got vented out to the atmosphere to begin with. But from the chiller's refrigerant perspective, that is the basic cycle. We come in here as a high pressure refrigerant, we get condensed into a liquid, that liquid then flows out back into the condenser as a high pressure liquid. And all this happens via gravity feed. The third secondary cycle for the refrigerant we will have, it kind of blends in with the oil system, and that is your inductor assembly, which is part of your oil return. But we use the refrigerant in order to create that. So what we have is, there on the bottom of our suction end bell, there is a low point where oil will collect. We will have a line coming off of that, runs down and ties into our inductor. This is on the outside of our oil tank assembly. We will also have a line coming off of our evaporator drawing back. It goes through a filter dryer and then into our eductor block. The third line that will tie into this is coming off of our condenser. So we will be taking high pressure gas and then flowing that into this eductor block. And essentially what is happening is this eductor acts like a jet pump. So a jet pump is another industry term for it, but in chillers, we refer to it as eductors. So what we're doing is we're taking this high pressure gas, we're pushing it through a nozzle assembly, and we're creating a Venturi effect. That Venturi effect creates a siphoning. That would be a way to simplify it. It's siphoning the oil that gets collected in the bottom of the compressor suction and the evaporator itself, and it allows us to draw that oil back into our oil tank. It is important to have an oil recovery system like this, because if we don't, then these points will allow oil to stack in them. And if we stack too much oil into the evaporator, we will begin to have higher approach values. We will not exchange heat properly. And then if we get too much oil stacking into our suction imbell and start to act like little pellets that can hit the impeller and start to tear it up. These impellers are made for refrigerant gas only. They're not made for any kind of liquid, including oil. So it is important that anything that builds up here is able to be drawn back off. So by using this process, after we pass through the eductor assembly and the high pressure discharge gas pushes through there and siphons off our oil back into our oil tank, we then have these vent lines, and these vent lines come up. Now these newer series will have this oil separator appear. We will go into these things in more detail in the oil cycle video I plan to do on this, but this will then just vent right back into the evaporator. And so all of the discharge gas and any liquid refrigerant that gets pulled in from, say, like the evaporator, all of that that enters our oil tank is allowed to escape via the vent line back out and leaving our oil contained within inside of our oil tank where we want it. And if you run across any of these older series CVH machines, there's not very many of them left out there, but they do still exist. You'll see they have a little bit of a different layout. Not only does our motor cooling circuit have a slightly different layout, and it returns to our low stage on the economizer instead of draining directly into the condenser, but even our eductor assembly, they call it an ejector at this time. This was before the term eductor was, I guess, widely accepted or utilized by the industry. Most all the manufacturers refer to it as an eductor now instead of a ejector or jet pump or whatever other term gets used for the same type of technology. Anyway, you can see the discharge gas coming off of the condenser flowing in. We have our suction nose cone drain, and then there's another line that it's here. It says from the evaporator is part of the ejector assembly, but it's not actually depicted. Where we're pulling off the bottom of the evaporator as well in order to get our oil return. You can also see here where the oil cooler used to be cooled by the drains, the drain refrigerant from the motor cooling circuit. Nowadays, it is done through the economizer, and we pass the oil through a heat exchanger in the economizer in order to maintain oil temperature. But it used to be done through a separate heat exchanger up here off of the motor cooling drain port. You could pause this video now and kind of get a good look at this older style machine. The modern manuals we're going to be looking at for these aren't going to depict this cycle, because this is a system from the 90s of just an old manual I had laying around, but just to kind of show you some of the differences on how things have changed over time. I want to say thank you to today's video sponsor, which is CSG, Compressor Solutions Group, based out of Houston, Texas. They've also got a shop in DFW serving the Texas area, and they also can provide you compressor service nationally. They're a great group of guys. They've done a really good job with just getting their information out there. They try to really invest into training in this industry and just supporting the contractors. Reach out to Jake with any questions you have. He'll be able to take care of you, be able to help you out. They do full service and rebuilds on screw compressors and semi-hermetic recips. They've been a great friend of the channel. They've been a great friend of mine. I look forward to working with them for a long time to come. So those are your 3 sub-refrigerant cycles for a CVH chiller. And whether it's a CVH-E, CVH-F, CVH-G, or a CDH, they're all used in the same system. The only difference between CVH and E and G or D, E and G are 3-stage impellers or compressors, and you can have a slightly different economizer due to the extra stages, where a CVH-F is only a 2-stage, and you'll only have, say, 1 economizer line coming off of the economizer returning to the compressor, whereas with a E or G series, you'll have 2. But this video combined with the first one I did for the primary refrigeration cycle is the complete refrigeration cycle that you will see for a CVH series machine. I will be doing a follow-up oil cycle video as well, so you can be looking forward to that. With that, if you'd like any extra chiller training, you want to advance yourself as a chiller technician, or you'd like to become a chiller technician, go check out chilleracademy.com. I have an introduction to chillers course to be perfect for you to go through. There's a lot in there, including covering a lot of the new technologies like VRF chillers, mag bearing chillers, and then going through a lot of the basic principles that some of which you may or may not have been taught as you were coming up if you didn't get proper professional training in this. If you're doing on-the-job training, much like I did coming up, and it took you, you're not getting consistent, routine, professional training other than just what you see and what you read, I highly recommend you take the time to go check out Chiller Academy, get inside of the Introduction to Chillers course, and get the extra education that you need to be successful in this industry. With that, MTT, make the time for your family, for your spouse, for your kids. I'll see you around.